One of the challenges of using Solidity to build smart contracts is there is really only one data structure in the Solidity language. So I want to go through an example of creating a data structure, which would be similar to a set or a map that you might find in another language. Now I've taken the liberty of creating a Docker file. This is what I'm going to use to build my project. If you look at my previous examples and videos, you can find how to create this Docker file and what's in it and the meaning of these things. For now, I'm just going to go ahead and use it. And right now, none of these things are going to work, so I need to comment out this section. Let me just go ahead and I want to open in the container so I have access to the foundry tools. I'm going to use that Docker file. Just say OK. Let's watch it start up. It only takes a second once you've downloaded the image. Then I'm going to create a new terminal. And we'll find that there's nothing here but my Docker file. So I'm going to use Forge, which is one of the main tools that comes with Foundry. And I'm just going to say Forge init. But what I find is that Forge init is unhappy because this Docker file is sitting here. I know that that Docker file doesn't interfere with what Forge init is going to do, so I'm okay with typing Forge init -- force. And this is going to set up an empty project. Okay, and it actually takes the liberty of creating some example code and everything that we would need. Now I'm going to go ahead and just reconfigure the project a little bit. I want my contract to actually be in a folder called contracts, which is a more typical place to find it. So I'm going to go ahead and move with source to contracts. Now, if I try to build this, I'm going to find that it's not going to compile because I've messed things up royally. Let's just try it. Okay, and it can't find things. And that's obvious because I changed the name of this folder. But now, if I fix that, let's see if it works. Okay, great. So we have an initial project that we can use as the basis for what we want to do. Let me just bump up this font here so that it's nice and legible. Okay, what I'm going to do is just simply use this as a basis point to start, but I want to rename things. So rename the source file, rename the test file. That no longer exists. That no longer exists. Let's create this, and let's just start with a blank project. Now, I'm noticing that in my project, I'm not getting any code formatting, so I want to install the Visual Studio plugin for Solidity. And we'll just go ahead and install, and that will help a lot with formatting and code recognition, and it gives you these pretty colors. Makes it a little bit easier to read your code. Okay, so all right. So what am I going to do? So I'm going to take advantage of the fact that there is one map, essentially one data structure in Solidity, and I'm going to use that to essentially build something like a linked list using that mapping data structure. So how am I going to do it? I'm going to create an integer. I'm going to iterate that integer every time I add an element to the set. And then I'm going to map from that integer to the element itself. So in this case, we want to create a set of addresses. So let's just create this element count variable that's going to represent the number of elements that we've seen so far. And I want to create a mapping, as I've said, from the integers to address. Now this could be a solidity struct or any other kind of thing in your set. And I could just initialize inline. Sometimes that's not a good idea when you're using proxies and other kinds of code. So I'm just going to go ahead and initialize in the constructor. It's really a personal choice, depending whether or not your code is going to depend on those things. And so what is it going to look like when we add to this? So to create the index of each element, I'm just going to pre-increment that counter. And I can just very easily assign it. Okay, and I've effectively already finished the implementation. I promised that I would return the index. But it's also common to emit an event when you make a state changing change inside of a data structure in Solidity. So I'm going to go ahead and create an event for that. Okay, now I've created the ability to add. I've noticed that this doesn't have its scope set, so I'm going to make that private. Unlike many programmers on Solidity, I generally always use the least scope that is necessary for any given element. I don't see any reason to expose this until there is such a reason. So how would we implement the getter? And we could make it public, but I don't think I'm going to use it internally right now. So external, again, I'm starting with like the least scope that I would use for any one of these. And we can always expand it later if that becomes a requirement. Now, what you want to do is simply return that index, the indexed address. But one of the challenges is that there are many indexes that are possible and only a few probably are relevant. And I notice here that I'm getting a warning. Without even compiling, I can see that this is not modifying the state of my class, so of my contract. So let's just make it a view. That'll quiet that noise down. And let's create a test to ensure that this index is a correct index. Solidity supports this construct called a modifier. A modifier is something that allows you to essentially implement guards, and guards can go before or after your code, In this case, I'm going to want to implement a guard before, so that if this index is invalid, then I'm just going to revert, and then it'll be as if nothing happened. And the first thing you need to know when you implement a modifier is there's this special little syntax, underbar semicolon, and underbar semicolon indicates where in the implementation of this, the actual code that you're going to guard should go. So you could either put it, as I'm going to do, require the guard to be run first before the code, or you could also have it run after to guard exit points. It's very common to have these guards run first, and it would only be a specific circumstance where the guard runs last. Maybe you want to validate the output of some method that you're working on. So what's a valid index? So if the index equals 0, that should be impossible because I'm using this pre-increment. That would be one case. Or if the index is greater than the element count, these should be two scenarios where that index is impossible. Then I want to revert, and how do I revert? So the old method of reverting is to revert with a string, but these strings take up a lot of space in your program, and code size is a premium in Solidity and in Ethereum and most blockchains. So let's just use another facility where we can define a custom error. In this case. Okay, now we can insert that here. And this code will simply be inlined into my function as the function gets generated, as if it was a guard that I implemented at the top of the function. But the nice thing is this makes my function just super simple. Now you think of it in terms of understanding it as just the most rudimentary case for this getter, and any specific guarding is then isolated into its own particular context of the code. Okay, so I'm happy with this partial implementation. So let's see if we can start to build a test around this. Okay, let's see what happens. All right, I'm actually able to build that. So let's see if I run my tests, if the test passes. Okay, great. And a lot of times you actually want to see the state dump of what changed in the test in case the test were to fail. We would need to be able to debug it. So I would use this argument -vvv, but in this case, the test is passing. So that's a good start, but I might also want to figure out how I could iterate over this object, because if I haven't stored all those indexes of the elements that were returned, I might still want to be able to iterate. So a size method might be nice. Let's add a test for that. I always pre-increment and for loops because it's more efficient for most compilers because they don't have to store a copy when they do the increment process. And I expect the set to have 27. So let's go ahead and build it and see what happens. Okay, there's going to be a problem. So it says explicit type conversion not allowed from uint 256 to address. And the problem is that an address doesn't support 256 bits in Solidity. So we want to use a uint 160 for this case. And now let's try again. Okay, so this is really starting to look like a kind of a useful set. So let's keep going. Another thing that people frequently want to do is implement some sort of a containment function. So how would we implement containment in this set? Now, you're pretty quickly going to see that the way that we've implemented this is essentially similar to a linked list, or maybe like a linked list implemented on the back of an array where we're using this mapping as a kind of dynamic array. So currently the best performance that we would expect to be able to implement would be linear, and I think we can do better than that. So what if we had a reverse mapping? Now, if we modify our add, to update this reverse mapping, the presence of whether or not this element is in the map is indicated by whether or not it has a non-zero index. So let's try that. And actually, we might even refactor out this part of it because that's sort of, you might also want to find the position of a given element. So let's go ahead and implement that as well. And we won't be able to access this find until we make it public. Now let's make sure we have test coverage as well. Permit me a little bit of copy and paste. Usually I like to use prettier. Right now I don't have that installed, but for this case I can use the built-in formatter. And we can also implement the find method. And let's make sure we don't have a duplicate method here. Okay, so that should now work. Okay, and this is one of the cases, so we have a failing test. What's wrong? Let's see what happened. So VVV prints out the full stack trace. Okay, so this is confusing because I just introduced address 0, and then I'm testing and saying it should be false. Actually, that is actually allowed because I've set it here. I was thinking in one index math when I wrote that. Let's see if it fixed it. Okay, that fixed it. So to round out our set, we may want to have an erase or the ability to remove an element from the set. So let's look at what that looks like. And I'm going to depend on that element present map that we just created. If the element's not present, I'm just going to simply return false. So now it would be common to just simply erase the element from the map. So let's go ahead and do that. What you do to erase in Solidity is usually overwrite it and then delete it. The reason for this is because there are some cases where elements can actually be brought back to life or you can see the data. So overwriting it kind of ensures that that will never happen. So just zero those out and then delete them. Now this would work. Make sure I fix this. I actually want the index, not the map. Luckily in Solidity, the maps have no meaning until they're dereferenced. Let's create a new event for this. Also, so that when we're changing the state, we can handle that. Okay. Now, this would actually work, but the problem is, so there's a couple of problems. One is we wish to decrement the element count because otherwise our size method is going to fail after an erase. But what we're actually doing here is deleting some element at an arbitrary index. So this could be anywhere. And just decrementing the element count is going to have the effect of deleting the last element, if you can imagine that. So in a way, we're creating a double bug here where we are deleting some middle element, creating a hole in our array or set, and then backing over the last element. So a better way to implement this erase method is actually to do a swap. What we should do is take this last element and swap that into the place or the spot where we want to delete the element. And then that way there's an element there so we don't leave a hole in our set or our array as we see it by forward iteration. And then just simply delete the last element. So let's re-implement that this way without this messy solution that has these problems. So this is the actual element in the last element. So let's pull that and then update everything. So now I've just overwritten essentially that index. And now I'm free to delete the way that I was going to delete it, the last element. Now I'm careful here to continue to mark this particular element that we want to delete as not present. This element is clearly, the last element is still clearly present, so I'm not deleting that one. And I just like to be in the habit of logging at the end of all the state changes, so I'm going to reorder that. Let's find out why it's complaining about that. Missing my E. Okay, typo. Let's try again. Okay, it seems to want to work, so let's see if we can implement a test for this. All right, so this deletes a particular element, then it checks the size and the containment still all work. Let's see if that works. All right, and that appears to work. I'll post a link to this project on GitHub in the comment section down below. And so this would be a useful set for any kind of accumulating a list of addresses, and something that you would want to be more dynamic is part of your smart contract.